Hello, welcome back to the last video for paper 1B for the May 2025 IB Chemistry Exams walkthrough. Okay, this is for HL only, the additional HL marks for question 3. If you're looking for the SL version, look here. I'm not like the HL versions that's in common with SL. It's just in the SL version. I'm not repeating myself. That's annoying. Okay, this is already like 3 hours worth of footage. Listen, okay, so we're going to do the HO only marks, which is just these 3 guys, okay? And this will be the last part for 1B. So this whole experiment in general, sodium hydrogen carbonate, some acid, CO2 is produced. You have, once again, paper 1B, you've got to imagine yourself in the lab, okay? You've got a vessel with most likely just the solid in it. You put it on the balance. You add your acid. You quickly record the mass, and then you record it like every 30 seconds because mass decreases because you're losing CO2 to the air. Okay. And so this part C is saying that the expected theoretical mass of carbon dioxide that was produced in a complete reaction for 1 moles decimeters to negative third HCl is 4.4 grams. Oh my God, theoretical yield, crazy. And then part 1 of this is saying to determine from the graph the actual mass that is produced. First thing we should notice is the concentration, because there's 3 different lines we can look at. 1 mole. So we're going to look at the 1 mole. We're going to look at this middle line, okay? And you may be tempted to go, oh, it's this final plateau. No, dog, imagine yourself in the lab. Imagine, okay? That is your vessel. The CO2 went away. That's not your final mass, okay? Your CO2 is going to be your initial, so starting up here, so that's going to be for this straight line, like roughly 9.1 grams. And then minus your plateau, because it's going to be a difference, the stuff you lost, okay? And so that is roughly around like 5.8 grams in that plateau. 5.8 grams, yeah, that tracks. It's just going to be 9.1 minus 5.8, okay? And I can't do math in my head because I'm stupid. So 9.1 minus, I just put plus, minus 5.8. So that's going to be 3.3 grams. So that's the answer for part 1. For part 2, it says to calculate the percentage difference. Keyword is percentage difference here. I actually had a brain aneurysm when I was taking this myself, and I misread that as percent yield. And I bet you all did too. You all were probably like, I don't know what that word means. Maybe you do. I don't know. Maybe you're not as stupid as I am. But you were like, I don't know what that word means. So I'm going to think it's yield. It's not. They're 2 different things. So percent difference is quite literally exactly what you would think from the name. Is a percent of the difference of how far off you are from the exact value. Okay. So it's going to be a percentage of the difference between the actual and theoretical. So 4.4 minus 3.3. They're going to just divide it by the actual value. So that 4.4. So literally a percentage representation of how far off you were. Okay. And then just times 100. And so if you do that, 4.4 minus 3.3 divided by 4.4 times 100, you end up getting 25%. And that is the answer to that one. Okay. For part 3, it says that although you have the same mass of sodium hydrogen carbonate and volume of HCl for each trial, the graphs began from different points. You had this, and this. So 2 of them started roughly around that not range, and then one was like 9.2. So there's like a 0.2 difference in that, which is slightly weird because, your mass and HCl are the same. So it should be the same. And so it's just an error in the method. And so when I chose myself, I did the most obvious route, which was in the mark scheme, thank God, so it wasn't, that would have been stupid, is I put the most simple reason, is once again, imagining myself in the lab. The only thing that's you're weighing other than the mass and the volume are your glassware. So you made the different glassware, brands or size, so you don't need a specific size for this, may have been used. Been used with diff masses for each concentration. Okay, So that was one of the options, and that was incorrect. But there were some alternative answers, as there always is with paper 1B. And so the other options that you could have said was that the recording of the mass started after the reaction started. And so it's kind of hard to see exactly the mass, if that makes sense. Like you immediately add it and you're like, oh, trying to get the starting mass like immediately, and it's kind of difficult because as soon as you add that HCl, it's going to start reacting. The button on the data logger was pressed too late. I think it's funny they accepted that. Random error resulting from reaction time. That is so incredibly vague, but they accepted it. So good on if you did that. Balance not teared / zeroed. Use of different beakers / glassware. Okay, I said that one. Glassware is not dried or cleaned from the previous trial. Not all solid liquid transferred. Because sometimes you weigh out the solid and then it doesn't, some of it is still on the like dish that you use to weigh it, the weighing dish. Calibration errors, lag time, whatever. All of those were options. Okay. So they seem to be pretty lenient on this one. Like they probably use this as a getting the marks up because people performed terribly on this one. So it looks like they accepted most things. Even if they were the most incredibly vague answers I've ever seen in my life. So that is that one. And that is the end of the paper 1B for HL. And thus all of the paper 1Bs. And now it's on to paper 2 in the next video.